then you start having semantic versioning issues.
Right.
But we can solve that.
Yeah, we can solve it. I would just like to say.
So let me tell you, these guys are doing the modular programming from the login, from the followers and the feed, and how they're going to improve it. And I'm going to dictate upon this. How I have implemented the same thing in my applications. So you see over there in all these modules, this is right now the degraded versions. The more you will add upon it, the more you are going to add on to the center API client. He will show you the second part of it, where the things will go like this. See, in this core package, which is having all my models, the domain one, which will not depend upon anyone. For the rest, everyone, let's say this is a networking engine, it will have its own protocol. So it's relying straight away onto the URL session protocol. This is an extension of URL request, which is what? Which is an extension of URL session. And you know that URL session is coming from this NS object. So he will tell us that there's one way that you can just extend the URL session and to get the things done. For the rest of this, you will find in the second chapter, that is every one of them will have a protocol. See, for the template engine, it has a template. It has a protocol which is following throughout template engine protocols. And you will find the template manager implementing this template manager protocols. Similarly, the same thing will go for the camera manager. The camera manager has a protocol. The camera manager has a protocol, and the camera manager will be implementing this protocol, right? Same thing will go with the data. Okay, same thing will go with the data. So this is the data engine. We have the data manager, and if we go over here, we will have the data manager protocol. You see, this is a long list of data manager protocol. Okay, and we have divided into figures like enrollment, inspections, data files, deletions, images, so forth as required. So you have a data manager protocols, and the data manager is implementing those protocols. One thing to be noted is this data manager protocol. This data manager is implementing this data manager protocol, and one thing is to be noted that these data manager, okay, how you are breaking it up through extensions. You see, this is the data manager. You are following this data manager protocols. In fact, it would be a long list of protocols. So how you are going to use this one? How you are going to do? So there will be like for deletions, extension data manager, we are handling this protocol. This is what this is coming from this protocol. Can you see this? Yeah, it is coming from the protocol. Same thing. So we are using extensions throughout this value. You are using extensions. Okay, that part is clear. That part is very, very much clear. This is a PDF. Okay, we need not focus on that one. What is the support manager protocol? So if we have a support manager, it will be implementing a protocol. So let's come back to this one, and then we will show you again.
Here that this modular approach
Okay.
is not for all apps. You know, if something is small and you don't are breaking,
It's easy to create and to use, but introduce some problems. So what we're doing here is making a case in one hit in modules.
So now he's refactoring the code.
A separate module for the API client. Initialize the client
Now everywhere
or the module.
they're going
we
to
have
put
a generic client in the middle, which even can make these whole API implementation.
Okay, so what is this guy saying is extension. Okay,
where we specialize the client for the module, and we have a generic client in the middle.
so what he has done is broken the client from this position, bifurcated it, like login separated over there, load separated over there, load follower separated over there. Now he has come back to this architecture, but this is not good. We want something better than that. The inversion of control. So this is the inversion of control.
Stop here.
right?
And eventually, when this gets too messy, the solution is to rewrite the application. Because that right to business is not the
Now we are going to refactor it such that instead of you depending upon this AP client, this will depend upon this login. So can you explain this? Let's say the client was making a login call or the followers call. Is it happening in your case? Let me have a look. So I have my networking engine. And you have the request builder. Let's see. You have the upload response, and you have this URL session fetch data. So what is this fetch data doing? This fetch data is okay. The fetch data as can be seen over here. Okay, this is coming from log request errors. Okay, and this is coming from this. So is it depending upon this one? API client depending upon login. API client depending upon followers or feed. Okay, those loggers are there for sure, but there is no way that is this depending upon that one. API client depending upon the login. No, that is not happening. For sure, this URL request extension is way better. Public extension URL session is way better. You have now fetch data. So this is used in the application. Let's see where it is used. Yeah, it is used right over here to fetch data from this. So you have a method right now. If you see, once you have built this one, fetch data, you have a method, URL session fetch. So URL session, which is nothing but an object, okay, is now commanding this value from this request. So it is used in the app auth manager. In the sync manager, it is used URL session.fetch data. And in the enrolling, it is used URL session.fetch data. So my model in communicating this is, instead of login depending upon the API client is depending upon this login. Is it happening over here? That was the question. So this fetch data is used in this application, and this one means, with application I mean module. Same thing, it is being used over here. So quite useful, right?
API client implementation and API requests. If you protocol or closures or any type of interface for the modules, for example, the logging, it needs a function or it needs a type that implements a function by talking to an API. The feed would need a function to load the feed. The followers would need a function to load the followers. And that's all they need. It doesn't need to know where it comes from. So when you have a concrete type dependency, as we have here, when the logging module directly references the API client, we depend.
This is very important. This should not be the concrete. This has to be a protocol.
And on the API client, we need to know how to locate the instance.
So that's the reason why, if you see in the applications all throughout, they'll be using the protocols. Let me explain that one. Let's say if you have a template manager and you have a template manager protocol, okay. So you'll find the template manager protocol being used over here, okay. It is observing this template manager protocol, and you see in the data manager itself, you are using this template manager, and you have this protocol, and you will be using this template manager, right? This template manager will be used all throughout. Let's say in the error, okay, we'll see, not over here. In the test, it is widely used. The test, it will be widely used, because what is this? Template manager is a protocol, right? Anyone that conforms to this protocol. Yeah. This will conform to the protocol. Yeah, this is the template manager, which is conforming to the template manager protocol, yes. So other than the test cases where it is used, I want to know that one. See over there, template manager, following this one. So it will be used. Okay, we have a lot of extensions basically in the PDF manager. We are registering it. Okay, I see that it is used mainly in the test cases. I would look for a better examples. Okay.
In the shared pointer. And then we need to invoke the function we want. When all we want is a function. So why don't we just depend on a function or on a protocol that implements the function? And now people start getting scary because, okay, this is not familiar. This looks weird.
Right. So I think you make some very good points here. First of all, it doesn't look familiar because there is this specialization that you mentioned before. So now what you're doing there basically is for the logging module, I need something to log me in, and I don't care about anything else. So the ease of use we talked before, by exposing a shared instance of this API client and being able to use it anywhere without any constraints, well, that doesn't specialize thing because all modules have access to everything else. However, what do I need as a login module, as a feed module, as a followers module? What do I need? You need discipline to ask yourself that, and you need to continue to answer this question and move on and actually implement that thing. That's why I think we don't see it often, and we hear so often about the rewrites for the features or the whole code bases.
Yes, and there's also good arguments against it because they say the API client should be very generic. You just make API requests, right? This API client can be a URL session, can be a level fire, or it can be your own facade. And you're just saying, this is the most generic thing, you just execute requests. And you say, okay, you can still keep this whole separation. You can go level 4.
Yeah.
And level 4 is you have your generic API client in the center, you have your modules with only what they need, and then you implement the adapters, probably in your main module, but it doesn't have to be. You can have your adapter module, you can have whatever you need. But now you start separating all the modules. Now, this is completely modular because you can use this API client in other applications. You can use the logging in other applications, in other contexts. You can use the followers module in other contexts as well. You can just compose all those things together, and when you're testing, you compose it with mocks, or you compose it with stubs. You compose it with whatever you need.
Absolutely.
You open up possibilities. Level 4.
Yeah, as I mentioned before, freedom. And the bigger the code base and the more complex it is, the more complex the requirements are, I think freedom is a tremendous asset to have. On the other hand, it doesn't come easily.
Clients came on client, but all we need is a function or a protocol with that function.
Functions. The main module can compose any functions, right? So this is very important as well here because we just abstracted the API, the remote part for these actions, logging and load feed. However, these are just signatures of these functions, right? Meaning that you can have a remote or a cast version, for example.
Yeah, you're free to.
Yeah, absolutely, absolutely.
So maybe you look at this diagram and you feel intimidated, but it's just because you cannot translate diagrams, concepts, modularity into code. Sometimes it's not as difficult as we think it is.
Working with protocols, yeah.
In the feed view controller, how easy would it be?
Yeah.
And it doesn't need to be a view controller, of course. You could be using a view model in here. Service, but it's not your concern where this API is, how to locate it in memory, what kind of implementation, what kind of concrete type I need to talk to. And then from all the methods it implements, which one should I call?
Because that's what we're doing here. We're doing separation of concerns basically. And each component, like this service or this view controller before,
of course, with an initializer. It's a client. First of all, I think that at this point, maybe this facade is not even necessary. But if you still need it and you want to test it without actually talking to a real API. Now, the way you're going to implement this API client, if you have this separation here, I don't care. It can be a singleton, it can be global state, it can be a capital S singleton, a lowercase singleton, it can be URL session, it can be AF network, I don't care. As long as my modules are abstracted from that, and I'm able to easily replace it, I'm able to easily compose those types together, I don't care about the API client. I have my preferences, how I would implement this, but then it's a personal preference. All I advise people to do is to go to step 1, 2, 3, 4, or maybe 5, 6 when needed, Just understand how you can go from one step to the other, understand the limitations of singletons with capital S, with lowercase s, and make the choices for your current problem. You can make singletons testable, and you can make lowercase singletons testable as well by property injection if you allow subclasses, for example. And then you can just transform your singleton into a global mutable state and replace it in tests. That's another approach. I don't recommend it. Most of the times it's not going to pay off, but sometimes it pays off. So maybe you start there, but know that there might be a problem. And when the problem occurs, you know where to go to the next step, and then to the next step, and then to the next step. Your code should be soft. That's the essence of software.
That's it.